All right, so I had some people asking me for more integration by parts examples. I'm always happy to help out with that. So let's look at one that's a little tricky, and I'll try to do it without consulting, like a formula packet or anything. So we got x times arc cosine of x dx, and I have a hard time remembering arc cosine's derivative, or I don't know its integral off the top of my head. So let's see if we can do a little side problem to deal with that. You're, of course, welcome to use your formula packet if you want. I'm going to look at y equals arc cosine of x, which means cosine of y is x, which means derivative, negative sine y times y prime is equal to 1, which means the derivative of y is 1 over negative sine y. And that's like super unsatisfying because we had a question involving the letter x, and so far my response to the question involves the letter y. So let's build a triangle. Remember, everything is triangles. That should be the title of my YouTube channel. So let's see here. What we know is that the cosine of y is equal to x. So that means that y is an angle. Cosine is adjacent over hypotenuse. So x over 1. And then over here, this side needs to be c squared minus b squared. And then we have a beautiful right triangle that relates the letters x and y. And so I can use that to substitute down here, and y prime is equal to 1. I guess I could move the negative up top. So negative 1 over sine, and sine is opposite over hypotenuse. So there we go. That's great. Okay, so we have go back to this here. I'm going to set u equals arc, I keep writing just one c, arc cosine of x, and then dv is x dx. So then du, we just figured it out, is negative 1 over the square root of 1 minus x squared dx. And v is equal to x squared over 2. So let's write out our integration by parts. uv, so we have x squared over 2 times arc cosine of x minus the integral of v, x squared over 2 times du. Great. Okay, so then let's clean it up a tiny bit. Two negatives make it into a positive there. Well, this kind of sucks also because um, the x squared shows up in two different places, and so I can't do just a simple u substitution. I could try to go back and do a trig substitution in there, and that might work out. Let's see if that works out. So I've got this triangle over here will still be useful. I'm just going to rename the y value as theta. So let's see if this works out. So I've got theta x root 1 minus x squared 1. So yeah, so we could say cosine of theta is x, negative sine theta d theta is dx. And like we said before, sine of theta is going to be the square root of 1 minus x squared. And let's just see if the trig sub takes care of our integral. So we still have this dude floating out here, x squared over 2 arc cosine of x. I'll pull a 1/2 here. x squared would be equal to cosine squared theta. 1 over square root of 1 minus x squared is 1 over sine theta. And then dx is equal to negative sine theta d theta. And so then that can cancel out with sine of theta. So we're getting somewhere. We still kind of have a tough situation. Arc cosine x. I'll pull the negative in front, so minus 1/2 cosine squared theta d theta. So now the question is, what the heck do we do with that cosine of theta? So here we're going to need to use a formula, but I'm stubborn and I don't want to look it up. So there is some formula that we could do with cosine squared theta where you rewrite it in terms of either cosine or sine. So here's what I'll do is I'll pause the video so I can write down where we're at, and then I'll clear the screen to give us a little more space. All right, so here's where we've gotten to so far. X squared over 2 arc cosine x minus 1/2 integral cosine squared theta d theta. So I remember that we worked on how if you have cosine of a plus b, you can end up with a double angle, with an angle addition formula for what that is. So we proved this by drawing out our picture. It ended up being cosine A cosine B minus sine A sine B. So go back and watch that other video if you want. But basically, the idea was you drew your angles, angle A, angle B, and then you had your right triangle like this, and you built another right triangle right here. And if you go through the process of writing out all your cosines and sines, you'll end up with that. So then what I know is that cosine of half of an angle plus itself is equal to then cosine of half of an angle cosine half of an angle minus sine of half of an angle sine of half of an angle. And so if I use that idea, I can say that cosine of theta is equal to actually, I'm changing my mind. Maybe I want to go the other way. So let's go here. Let's just make this into theta plus theta. I think it's easier to go that way. So then I have here cosine of 2 theta equals cosine squared theta minus sine squared theta. And I know from the unit circle that cosine squared theta plus sine squared theta equals 1. So if I substitute that in either for sine or for cosine, I would substitute it in for sine because I see this part matching up with my integrand there. And so if I substitute this in for sine right here, I have cosine of 2 theta equals cosine squared theta minus 1 minus cosine squared theta. So in other words, we get 2 cosine squared theta minus 1, because I distributed the negative sign through. So now we have a double angle formula, cosine 2 theta plus 1 divided by 2 is equal to cosine squared theta. So all that hard trigonometry work was just to get us another little substitution here. Arc cosine x minus 1/2 integral cosine 2 theta plus 1 over 2 d theta. So now I can take the integral of all that. So I'll make this 2 go combine with that to make a fourth. The antiderivative of cosine is sine. Because it's a 2 theta, I do the reverse chain rule, divided by 2. The antiderivative of 1 is just theta. So now I need to remember what our theta was represented as. So this was our right triangle from before. Theta x 1 minus x squared, like that. And so we can write our final answer back in terms of x. Sine of 2 theta. I guess I could use another angle addition formula. That's kind of ridiculous. So what does sine of 2 theta equal in terms of theta? Yeah, so sine of 2 theta, just like cosine has an angle addition formula, let's create a little bit of space. So sine of a plus b equals, what is it, sine a cosine b plus sine b cosine a. Yeah, that's right. So if you just have a and b equal each other, you're just going to get 2 sine theta cosine theta. All right, we're almost there, folks. So we have 2 sine theta cosine theta over 2 plus theta. And now we can actually write our final answer. Arc cosine of x, the 2 over 2 cancels, minus a fourth. Sine of theta is opposite over hypotenuse from our triangle, 1 minus x squared. Cosine theta is just x. Theta is just arc cosine of x. And then, of course, at the end of it all, you pull your head above water and you put a plus c on the end. So that was made a little bit more challenging by my stubborn insistence on deriving the trig formulas throughout. If you just look at your formula packet, you'll see there's a nice formula for when you have a double angle. You'll see there's a nice formula for when you have cosine squared to reduce it down to cosine 2 theta plus 1. Like there's these, you can use the formula packet as you go through it. I just stubbornly insist when I'm making a video as much as I can to show you where those formulas come from. So please comment, let me know if I made a mistake or if there's anything I can do better.